Hi guys, this is the last screencast we're going to do on the respiratory system, and we're going to be looking at the responses and adaptations of the respiratory system to a single sport or exercise session. Okay, so before we actually go on to what the responses are, before we do the adaptations, it's important to know that respiratory system is all to do about delivering oxygen to the working muscles and removing carbon dioxide. So the responses and adaptations to this system are going to greatly affect our efficiency and our ability to deliver oxygen and remove carbon dioxide. To try and get that into your head now with regards to the respiratory system, it's all to do with delivery of oxygen, removal of carbon dioxide. So you need to be aware that the body is really sensitive to increased levels of carbon dioxide. As soon as our body feels an increase in carbon dioxide, chemoreceptors send a message to the brain and then tells our respiratory system to react in an appropriate way. Okay, so the more intense the exercise, the greater the carbon dioxide concentration in the blood will be. To combat this, we have basically an increase in our breathing rate to ensure that carbon dioxide can be expelled through breathing out expiration. Okay, so first of all, once again, question, circle input information, memory method, translate, extended example. You need to be following this profile throughout your whole exam revision, as well as in your actual exam that you're taking in the future. So, responses of the respiratory system to a single sport and exercise session. There are only two to remember. There isn't a memory method for this because there is only two. See if you can guess it from those blanks. But remember what I said with regards to it's all about delivering oxygen to the muscles and removing carbon dioxide. So we've just started to exercise. What do you think is going to happen to our breathing? You all would have experienced this when you've actually taken part in physical activity yourselves. If you pause this and give that a go. Okay, so the answer, increased breathing rate, increased tidal volume. Now there are reasons why we have an increased breathing rate and increased tidal volume, and there's reasons for it. So again, all I want you to do here is just fill in the gaps. First of all, you'd start a question if it's asked you about the responses or immediate effects of exercise on the respiratory system. You'd first of all, okay, breathing rate. Then you just quickly put what breathing rate is. It's the amount of something, 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 something. Okay, prior to exercise, our breathing rate increases slightly. What is this known as? It's exactly the same as what happens to our heart rate. Okay, so if you just pause this and answer that. It's known as an anticipatory rise, and this is due to the release of adrenaline. It's exactly the same again. Anticipatory rise is due to adrenaline being released. It sends a message to the brain, which speeds up our breathing rate and increases our tidal volume. Why does our breathing rate increase during exercise? Give that a quick go. Of course, it should do with the muscles demand more something and produce more so on, and you can fill that in. And then we're going to do the same for tidal volume. So if you can just have a look at that, pause this and fill in the gaps. We'll go through the answers on the next page. So you should have, we'll start right down here. So muscles demand more oxygen and produce more carbon dioxide. Chemoreceptors detect an increase in carbon dioxide, send a message to the RCC. This increases our rate and depth of breathing. This means the performer can perform for longer at higher intensities, reducing the effects of fatigue. It's all about that delivery of oxygen, removal of carbon dioxide. This is going to make the performer be able to last for longer at higher intensities, reducing the impact or effect of fatigue. Tidal volume is the amount of air inspired or expired per breath. This increases during sport to allow more oxygen to the working muscles and to reduce carbon dioxide from the body. That should be removed, apologies. This is due to the chemoreceptors detecting an increase in carbon dioxide. It's very self-explanatory. Our breathing rate increases, or our depth of breathing, or the amount of air we inspire or expire. It all happens for the same reason, to bring in more oxygen to the working muscles and to remove more carbon dioxide. And this happens because chemoreceptors detect an increase in carbon dioxide. As I said earlier, the body is really sensitive to increases in carbon dioxide levels, so it responds in this appropriate manner. So again, not very clear. This is a question that's on January's exam. Farzana is a 10,000 meter runner. She is in the middle of her athletic season. She is competing in races and she is also doing her training program. Explain two immediate responses, i.e., explain two immediate respiratory responses for Farzana when she is competing in the 10,000 meter race. So what two responses have we just looked at? If you can answer this and try and get 4 marks, 2 marks per question, so 2 points per respiratory system response. That's the answer we're looking at. Okay, so if you just read that, get that down, that'll help you out in regards to when it comes to the exam, what they're looking for. Remember, again, it's all to do with what each one actually is, what's the definition of it. Adaptations of the respiratory system to exercise. Unfortunately, I've forgotten to do this in animations, so you've got the answers right there. But what we get, so adaptations, how does our body adapt to a training program that is trying to improve our aerobic capacity. We get an increase in vital capacity, increased strength of respiratory muscles, increased oxygen and carbon dioxide diffusion rates. So, increased vital capacity, if you go through that and try and fill in the gaps for me, just pause this and give this a go, and we'll go through the answers in a minute. That's really important. Okay, all of these mean that oxygen uptake is improved. It means that more oxygen gets to the working muscles, performer can last for longer at high intensities, reducing fatigue because more carbon dioxide is being removed with each breath as well. So answers: increased vital capacity. Okay, this is the amount of air that can be forced out of the lungs after maximum inspiration. This means more oxygen can be delivered to the working muscles when we do our maximal inspiration. It means more carbon dioxide can be removed, which means we're going to be able to perform for longer at high intensities, reducing the risk of fatigue. Increased strength of respiratory muscles. We should know, because of the mechanics of breathing, our respiratory muscles are our diaphragm and our external intercostal muscles, as well as our internal intercostal muscles as well. These kind of improve in strength, which means that our thoracic cavity expansion is even larger, which means we can get more oxygen on board, more oxygen to the working muscles, which means we're going to be able to perform for longer at high intensities because we're also able to remove more carbon dioxide as well. Our muscles are stronger. We can lift our rib cage further, more, greater. Okay, so it's just about getting more oxygen on board. Okay, last one: increased oxygen and carbon dioxide diffusion rate due to capillarization. Capillarization is basically when capillaries multiply, we get more capillaries. So around the alveoli we have capillaries, and that's where gaseous exchange take place. Well, we actually get the adaptations we get capillarization happen. We get more capillaries around there, which means more blood flow is going in and out of the lungs. This allows better delivery of oxygen and removal of carbon dioxide to and from the working muscles. All these three impact by meaning that we can perform for longer at higher intensities, reducing the risk of fatigue. As I said, respiratory system is all about oxygen delivery and removal of carbon dioxide to improve sports performance by making us survive or last for longer at higher intensities. As I've just said, there you go. Finally, wanting to answer his question, 6 marks. Assess the adaptation to Marco's respiratory system at the end of his 6-month endurance training program. If you pause this and give that a go. Okay, answers. Now, realise we have not spoken about maximal breathing rate, increased lung capacity, increased pulmonary ventilation. However, vital capacity, if you talk about vital capacity, all of a sudden you're almost talking about tidal volume within that anyway, so you'll get your marks for that. We have spoken about increased strength of respiratory muscles, increased capillarization. Okay, and then you can go on to say the increased number of alveoli enables more gaseous exchange to occur, steeper diffusion gradient created, which means more oxygen can get to the working muscles, and just the fact that gaseous exchange becomes more efficient. It becomes more efficient because we have more capillaries and we're able to breathe in more oxygen, well, more air, I should say, per breath. Okay. That's all I want to say for this screencast. Now, I am going to quickly just show you slides on the additional factors of the respiratory system with regards to asthma, but I'm not actually going to go through it. Okay, I want you to do this in your own time. You've also got to look at and research the effects of altitude on the respiratory system. Now, this is on Moodle under one of the PowerPoints, and this is something that we went through in lesson. So here are the PowerPoint slides for this. If you just pause it and write notes on it.